All right, so I kind of did the unit circle yesterday because I knew people were going to be gone. So today we're looking at the unit circle. So you have to remember whenever it says that it's on the unit circle, that we are saying that it has a radius of 1. Okay, and so it's just trying to make this a little bit easier for you. Oh, and I didn't grab my phone in here, so I don't have a calculator, but that'll be fun. So anyway, so if I look at this first one, it wants me to find the coordinate of the point of the missing coordinate. So I want to find y, and I'm telling you that I'm in quadrant 2. So if I'm in quadrant 2, this is a negative 0.6, this is y, and this is my hypotenuse, which I'm on the unit circle. It says right there. So I'm going to do 1 squared minus 0.6 squared. So that's going to be minus 0.36. And that equals y. So that would give me, I don't have a calculator. So if I mess up on any of these, just know Miss Williams always messes up. So I believe that is 0.8. Okay. I am in quadrant 2. So my y value would be positive. Okay. All right. So on the next one, I am in quadrant 4, so I don't know the x, but I know the y is negative 8/17, and then this is 1. So I would do 1 squared minus 8/17, which is that 64 over 324. I'm just going to do this quick because I do not want to have to go find a calculator. So I'm doing 1 minus 64 divided by 324, no, 17 squared. Better just do 17 squared because I think that's 289. Okay, I should just go get my calculator. Gonna pause for a second and go grab it because I don't want to do decimals. This one works out nice. So if I do that on my calculator, I get 225 over 289, and then that's what x squared is equal to. Equals x squared. So that's 225 over 289. So then I would square root that, and my answer would be 15/17. Okay. And so on the next one, you're going to have to pay attention to signs. If I'm in quadrant 4, it's going to be positive. So on the next one, I'm in quadrant 3. I don't know my x, but I know my y is negative root 13 over 7. And that's 1. So I'm going to do 1 minus 13 over 49 equals x squared. So 1 minus 13, I think that's 36, isn't it? Yep. So that's x squared equals 36 over 49. So when I square root that, I get 6/7. But I'm in quadrant 3. So it's got to be a negative 6/7. So you're going to have to pay attention to the signs. So it's going to tell you it's on the unit circle, and you're going to have to solve it. On the next one, verify. So the word verify means that you have to prove that it's true. Okay, so to verify, if this is my x and y, then I know that this squared plus this squared has to equal 1. So if I verify it, I would have 7 over 16ths plus 9 over 16ths. Well, that equals 16 over 16. So I just verified it. Okay, so you're going to do the next one. So you're going to square them both. So this would be 6 over 9 plus 3 over 9, which equals 9 over 9. So I just verified it. Okay, the next one with the decimals, this is going to be a little trickier on your calculator. I'm actually going to type it in so I can see. Because we are rounding them, it's not going to come out exactly. 2029 squared plus 0.9792 squared. And when I put that in the calculator, it gives me 1.005000105. So this is really close to 1. So when you're dealing with decimals, that's why we are using the exact fractions, because it does make a little bit of a difference, but that just does verify. Okay, the next question is saying find the reference angle. So this gets a little, I would you got to remember, reference angle, the definition is it is the closest to this x-axis, right? And so if I do this, if I start here, right, and I go all the way to here, isn't this going to be 3 pi over 3? And then if I go to here, isn't this 6 pi over 3? So isn't 5 pi over 3 going to be right here short of it? So my nearest x-axis is 6 pi over 3. So my answer, my reference angle is pi over 3. Okay, these are a little easier if you count and draw. You do not have to. But if you think about this, this is 0. This would be 3 pi over 3. This would be 6 pi over 3. That's still not close. So then I'm going to go 9 pi over 3. And then I'm going to go another one. So this is 12 pi over 3. Well, 11 pi over 3 would be right here. So my reference angle is pi over 3. That's how we did these when we did them in degrees. You thought about how close it was to the nearest x-axis. So now I'm going to count by fourths. So pi over 4, this would be 4 pi over 4, 8 pi over, oh, it's negative. Sorry. So I'm going to go this way. Negative 4 pi over 4, negative 8 pi over 4. So I'm just counting until I get to the closest one. So wouldn't a negative 7 pi over 4 be right here? Remember, reference angles have to be positive and less than 90, which is less than pi over 2. So my answer to that is pi over 4. Okay, these would be without a calculator. So let's just discuss this. These are all over 4. So that means that they're all 45 degrees. They're all sines. So that means the sine of 45 is equal to root 2 over 2. And if you need to draw the triangle, you can, but hopefully you've done enough. Okay, so your only thing is going to be to find the sign, S-I-G-N, like where is it located? So here would be 1 pi over 4, 2 pi over 4. Here is 3 pi over 4. So the sign, I am going up in that quadrant. So my sign is positive. So my answer on this would be root 2 over 2. Now I'm just going to keep counting. So this is 3 pi over 4. This is 4 pi over 4, 5 pi over 4, 6 pi over 4. Here's 7 pi over 4. So that is going down. So this answer is a negative root 2 over 2. Okay, I'm going to just use a different color. If I start back here, isn't a negative pi over 4 going to be straight down? So that's a negative root 2 over 2. And now I'm counting. Here's 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's still going down. So that's a negative root 2 over 2. So it's going to be a matter of using the information you know. This will be on the no calculator part of the test. Okay. All right. Find the unit circle point that are on the terminal side of the given angles. Okay. So if you think about this, the terminal side on the unit circle means that the cosine of theta is going to give you the x, and the sine of theta is going to give you y, because opposite over hypotenuse, the hypotenuse is 1, right? So if you look at this, you literally, all you have to do is type in the calculator, the cosine of 140. Okay, so I'm going to look in my calculator right now, and I can't show it to you because it doesn't allow me to do that, but up in the right-hand corner, it says DEG. So these are degrees. So I'm literally just typing the cosine of 140, and it tells me a negative 0.766. And then I'm going to type the sine of 140, and it tells me 0.6428. That is my answer. So again, logically, this is hard, but like mathematically, I just have to type it in my calculator. So the next one is the cosine of 339. So that's 0.9336. And then I'm going to do the sine of 339, and that is a negative 0.3584. Okay, and that makes sense. It's in quadrant 4, so it should be positive, negative. Now, the next part is the first time you're going to have to change your calculator. So if you look at the toolbar, it has up in the top by the red X. If you click on that toolbar and you go to Document Settings, Okay, you're going to go to document settings, and the second one from the top says angle. You're going to go to degree, and you're going to change it to radians. So it's a drop down menu, and you're going to change it to radians. So you're going to click on the right side, there's an arrow, and you're going to change it to radians. And then down at the bottom, you're going to go to make default. And when you come out of there, and when you get out of this screen, so I'm making default, sorry, and you hit OK. When I come out of the screen, it says RAD at the top of my calculator, where the DEG used to be. Now it's in radians. So I'm literally going to type the cosine of 1. And it tells me 0.5403. And I'm going to type the sine of 1. And I'm going to tell you right now, these are the most missed questions on the test. Because I don't think kids understand when you're on the unit circle, the cosine is the x and the sine is the y. And they're giving you the angle, so you literally just have to type in the cosine of 4, negative 0.6536, and the sine of 4. If you are not getting these answers, then your calculator is not set in radians, 0.7568. Okay, so this is just really making sure you understand your calculator. Okay, all right, so let's take a look at the next example. These are all over 6, and I will definitely do this for you on the test. So if I think about it, 180 divided by 6, I'm cutting pi into 6 equal pieces, is 30 degrees. So this is a 30-degree triangle. So 30, this is, let's make the hypotenuse 1, which would make the short leg 1/2, because we want the hypotenuse. So we're on the unit circle, right? And this would be root 3/2. Okay, so if we think about this in terms of this circle, right, I'm just going to write this right here. Pi over 6 would be right here. So wouldn't that answer, the cosecant is the flip of the sine, so aren't all of these answers going to be 2? Every single one of these, because they're all cosecants, these are all 2. The only thing I got to check now is the sine. Okay, so I'm going to just keep using this. So pi over 6, this would be 2 pi over 6, 3 pi over 6, 4 pi over 6. Here is 5 pi over 6, 6 pi over 6, 7 pi over 6. Cosecant is sine, it's going down, so that's a negative. 13 pi over 6, well, wouldn't 12 pi over 6 be all the way around? So isn't 13 pi over 6 the same place as pi over 6? So it's positive. And a negative 11 pi over 6 is in the same place, so that's a negative. I have 5 pi over 6 marked right here. I am going up, so that one's a positive. And then 11 pi over 6, so here's 7 pi, 8 pi, 9 pi, 10 pi. Here's 11 pi over 6, so that's going down. That's a negative. A negative pi over 6 is the same. These are actually the exact same answers. Now, this is the hard one, 17 pi over 6. Here's pi over 6, 6 pi over 6, 12 pi over 6. Oh, it's negative. I always do that. Go the other way. So here is 6 pi over 6. Here is 12 pi over 6. Here is 18, negative 18 pi over 6. So negative 17 pi over 6 is going to be straight down from it, which means it's going down, so it's a negative. Okay. And then, yes, this is the last one on tonight's assignment. It just wants you to define all 6 trig functions if it's on the unit circle. So if it's on the unit circle, this is my cosine. So my cosine of theta is 15/17, which means my secant of theta is 17/15. Okay, and the y is my sine, because that's my opposite. So my sine of theta is a negative 8/17, and my cosecant of theta is a negative 17/8. Now, tangent is the hard one. So if I draw this triangle, oops, it's going to be going down, not up. So if I draw this triangle, it's down here in quadrant 4. This is 15/17. This is negative 8/17. This is 1. And when I do tangent, that's opposite over adjacent. So when I do tangent, I'm going to do the y divided by the x. So I'm going to multiply by the reciprocal. 17s cancel, and I get a negative 8/15. So then the cotangent is easy to do because you just flip that, negative 15/8. Okay, which is rise over run. The tangent is the slope of the line that goes through that origin. All right, so let's take a look at the next one. So if I do the cosine of theta, that is a negative root 21 over 5. If I do the secant of theta, that is a negative 5 over the square root of 21. I do still want you to rationalize in this chapter on a question like this. Okay, we probably won't do that much longer. Then the sine of theta is negative 2/5, which means the cosecant of theta is a negative 5/2. And then finally, the hard one, but it's the same thing every time, is just your rise over run. So negative 2/5 divided by a negative root 21 over 5. So negative 2/5 times copy dot flip. Those cancel, and you get a negative 2 over, negative over a negative is a positive. Let's just go there. Okay, and so I now know if I flip that, that is my cotangent. So my cotangent of theta is root 21 over 2. And then if I rationalize this, that's 2 root 21 over 21. All right, so that should get you on the first worksheet. If you're missing any worksheets, please email me. I am pretty sure I put them into the Google Classroom, but I will double check.